So taking a look at some things for 9-4, one of the things I want to go over is the square root. So one of the things I want to do is what I call the rule of twos. Or you can maybe call it the rule of pairs. That might be better. Now, this isn't like a theorem or anything. This is just something I'm kind of making up, but hopefully it'll help. But it works like this. I'm going to grab some pens. So what we're going to do let's say we have something like this. Well, what this rule of pairs says is every time you have a pair of the same number in a square root, they'll pop out as a single number. And then whatever didn't pop out using the rule of pairs stays behind. So you're going to get something like this. And so what we're left with is 2 times 3, which is 6. So this will become 6 square root 5. Now, let's take another look at another one of these. So let's say we have something like this. Well, in this case, we have one pair of 3s, and that's the only pair of numbers that we have. So we'll get 1 3 to pop out using this rule of pairs. And so we leave behind a 3 times 2. And what we get is 3 square root 6. Now, the problems that we've been doing in 9.4 is we don't get something like this automatically under the square root. Usually what we'll have to do is we'll have to take a number and we'll have to break it down into what's called a prime factorization. So prime numbers. Now, if we think in terms of just positive whole numbers, no fractions, no decimals, no negatives. Prime numbers are only products of themselves and the number 1. So what 2 numbers can you multiply to get 2? 1 times 2. And again, we're leaving out fractions and decimals and negatives. So with just the positive whole numbers left, sometimes they call these the natural numbers. Well, just 1 times 2. 3 times 1 gives you 3. Only 5 times 1 gives you 5. Only 7 times 1 gives you 7. Same with 11, 13, 17, 19, 23, and so on. And there's infinitely many prime numbers. And well, this is the beginning of the primes. So a prime factorization is we rewrite a number as a product of primes. So you might have seen something like this before. So let's say we have 50. Well, 50 is 2 times 25. And 25 is 5 times 5.
Is it called factorization?
I'm sorry?
Prime factorization?
Prime factorization. Oh, factorization. I'm sorry. Thank you. One too many R's. So prime factorization. And you're going to keep breaking the number down until you get just prime numbers. And you can break it down different ways, but you're going to get the same result. So this could have been 10 times 5. This would be 2 times 5, and still a 2, a 5, and a 5. So there are different ways of going about it, but you're going to get the same result. And what this result is that 50 is 2 times 5 times 5. So when we're dealing with these square roots, what we're going to want to do is break numbers down into their prime factorizations. And this will become 2 times 5 times 5. And then we can use that rule of pairs. So that pair will become a single number outside the square root. And then what's left behind is a 2. And so that's how we can get our answer. So questions about that? Or let's see here. Let me take a look. I'll pull up a problem to work on here. So let's say all right. So let's say we've got this. Now, again, I recommend using the quadratic formula. So we want to get this in standard form. So we want everything to one side with a 0 on the opposite side. This will be y squared minus 6y minus 4 is equal to 0. So in this case, our a is 1, our b is -6, and our c is -4. So now we use the quadratic formula. So negative b and then there's b squared minus 4 times 1 times -4. And then divided by 2 times 1. So as we simplify, negative and negative is positive. And then we're going to have the square root of 36, because -6 times -6 is 36. Negative times negative is positive. So 4 times 1 times 4 is 16. And then we have that divided by 2. So continuing on with our simplification. This will be 52 over 2. So we got to take the square root of 52. So what we can do is use our rule of pairs. So first off, we take 52, and I mean, it's an even number, so it's always divisible by 2. So I'll divide it by 2. 52 divided by 2 is 26. 26 is an even number, so that's divisible by 2. 2 times 13. So this says that 52 is 2 times 2 times 13. Here, I'll just circle these prime numbers. So instead of the square root of 52, let's write square root of 2 times 2 times 13. And now, if we use our rule of pairs, there's a pair of 2's, and they're going to pop out as a single 2. And then the 13 is left behind. So what we can do, there's one more thing we can do. We can factor out a 2. Now, factoring is the reverse of distribution. So if you think about distribution, let's say we have this. So the distribution says we can simplify this or drop the parentheses if we multiply the b and the c by a. And this is true if you have a minus also. You can do that also. And so you'll get this. So this is what's called distribution. Now, what we want to do something else. We want to factor. So factoring is going to be this. If we see something multiplied to each term, we're going to pull that out. And so we get a times b plus or minus c. And this is called factoring. So we have distribution here. In factoring, we're just going to undo that distribution. So how is it helping us with this problem? Well, it doesn't hurt to look for something you can factor out. And the way we can think of this, 6 is 2 times 3. So that means in the top, and remember, 2 next to the square root, that means 2 times the square root. So we can factor out the 2. And now, there's one more thing. Just like we can reduce fractions by canceling a number that appears in the top and in the bottom, we can do the same here. So this is 2 times this quantity. So it's okay you can cancel these. Another thing you can do is divide top and bottom by 2. It'll have the same effect. But you can do this. So what we'll have these will be our 2 answers. So questions about that? So let me do another one. Let's see here, looking at the problem set. So let's say we have this. So what I'm going to do, I'm going to subtract z from both sides and subtract 4 from both sides. So taking a look at this, my a is going to be 1. My b is going to be -1, and my c is -4. So again, using my quadratic formula. And now we have -b, and b is -1, plus or minus square root of -1 squared minus 4 times 1 times -4 divided by 2 times 1. So this will become 1 plus or minus. This will be 1. Minus and minus is positive, and then 4 times 1 times 4 is 16. And then divided by 2. Or 1 plus or minus the square root of 17 divided by 2. Now, at this point, we want to think about taking the square root of 17. But 17 is a prime number. So we can't really use the rule of pairs on 17 because 17 is just 17 times 1. So since it's a prime number already, it's just going to be left behind. So what we'll get, and there's nothing we can factor either on top. So this one will just be and that's going to be it. So any questions about that?
Just give me 1 second to write the bottom 2 answers, but like I got most of it all the way down.
Oh, I'm sorry. Oh, I'm sorry, what did you say?
I said just give me 1 second so that I can get the bottom part down, the plus or the minus, but when you separated it, I just need a second. But I think I got it.
Awesome. Okay, let me take a look at another problem to do. Let me see. All right. So let's say we have this one. Is it okay if I erase this here?
Go ahead, thank you.
So I subtract 4 and 4r and subtract 7 from both sides. I'm going to get this in standard form. And so again, I look for A, B, and C. A in this case is 1, B is -4, and C is -7. So R is -B plus or minus the square root of B squared minus 4AC divided by 2A, or -4 plus or minus the square root -4 squared minus 4 times 1 times -7 over 2 times 1. So we get 4 plus or minus the square root of 16 plus 28 divided by 2. And again, it's going to be plus 28, negative, and negative. So we get 4 plus or minus the square root 44 divided by 2. Let's see here, is that, let's see, 38. Yeah, that's right. So for this one, we're going to use the rule of pairs, and we're going to use factoring. So first off, square root of 44. Well, we want to break down 44. So 44, it's 11 times 4, and then 4 is 2 times 2. So 44 is 2 times 2 times 11. So if we take a look at this, you have 4 plus or minus the square root of 2 times 2 times 11 divided by 2. So now we can use the rule of pairs for square roots. So there's a couple 2's, and they will pop out as a single 2 in front of the square root. And they're going to leave the 11 behind. So is there anything we can factor in the top? Well, 4, again, is 2 times 2. And sure enough, there's a 2 and a 2. We can factor out a 2. And just like with reducing fractions, you can cancel those 2's. You get 2 plus or minus square root of 11, or 2 minus square root 11, 2 plus square root 11. And that's going to be it. Questions about that? So I just want to mention, let's see here. So if you're doing your rule of pairs, so just a little note on this. If you're doing your rule of pairs, like let's say we're taking the square root of 36, and you get something like this. Let's say we factor 36. So we'll get the square root of 2 times 3 times 2 times 3. And we could rearrange the order here. As with multiplication, you can do that. In this case, pair of 2's becomes a 2. A pair of 3's would become a 3. So what's going to be on the inside of the square root? Well, what you can say is that once you use the pair of 2's and there's nothing left, the square root goes away. It doesn't become 0. It just sort of cancels. And so you'll get 6. So it'll just cancel out. It doesn't become 0. It just cancels out, goes away. So I think that's it. Other questions for section 9.4? Hopefully that rule of pairs helps.
Yeah, the rule of pairs really helped. I was just I guess I was going over. Hold on, I gotta double check exactly where it was. But you said
Sure.
you had something else you were gonna go over, right?
I could start in the 10.1. I mean, I'm not in any hurry at the moment.
Okay. I have to go back in and check really quick, but you can continue and I'm paying attention.
Okay. Well, for these problems, I want to show you the factoring techniques. There are a couple factoring techniques, and I'll go over those. I'll go in more detail. We looked at them very briefly last time. So the first one I want to go over is what's called guess and check. So for guess and check, this works with a very particular quadratic equation. X squared plus, I'm using capital B, bx plus c equals 0. And the key thing here, there's a 1 on the x squared or on the squared variable. So this is how guess and check works. And again, it might not be possible. This doesn't always work. But you're looking for two numbers, a and little b, that add up to capital B, but also multiply to capital C. And when you find these two numbers that do this, this automatically becomes this. So this is a way of factoring. And so then what you're going to use is what's called the zero product principle. You're going to get two equations. One, x plus a equals 0, and the other, x plus b is equal to 0. And the reason this is true, if something's equal to 0, then, and you've got this multiplied to this. Well, for this to equal 0, this has to be 0, or this has to be 0, or both are 0. So this gives you two equations to solve, and then you just solve for x in these two equations. And what you end up getting is x is negative a, x is negative b. And so those become your answers. And again, this method only works. I'm going to go through a couple examples. It only works if there's a 1 in front of your squared variable. So let's say we have something like this. So what we want are two numbers, a and b, that add up to the number that's on the variable that's not squared. And these same numbers, they need to multiply to be the number that doesn't have any variables attached. And so basically you just guess. So I need a pair of numbers where they add up to 5, but they multiply to 6. And so what you'll get, a equals, oh, sorry.
I'm sorry, I missed like half of that. I got like the first part of the problem and I started writing a plus b equals 5, and then I kind of missed what you said there.
Oh, you mean this bottom part here?
Yeah. Please.
No problem. Is this okay?
Yes, let me just, I'll let you know, I'm almost done with it. I got up to 0, and then I'm going to go ahead and factor, or the how you did the x plus a equals 0. I'm writing that part now.
All right, no problem. Well, for guess and check, I'm just going to write in the b here. You might, guess in two numbers that add up to 5. Well, 4 and 1. But 4 times 1 doesn't give you 6, it gives you 4. You might go with negatives. You can go 7 plus negative 2. That also equals 5. But 7 times negative 2, that's going to be negative 14. So that's not going to work. So you might have to kind of guess and check kind of creatively. Like you'll get some negative numbers in here. But once you do have it, a plus b will give you 5. A times b will give you 6. So once you've got that figured out, then you can move ahead. Is it okay if I erase this?
Yes.
So you get x plus a, x plus b, and that's equal to 0. And so now you need to solve the two equations. X plus 2, well, this could be 0, which makes this whole thing 0. Or x plus 3, that could equal 0. And that's what's making everything 0. And then the way you solve, for adding 2, we do the opposite, we subtract 2. Same with this, subtract 3 from both sides. And so we'll get x is -2, x is -3. So for your answer, it's -3, -2. And so that's how you could use guess and check. Now, questions about that?
Yeah, that's it.
All right. So let me do another one. So again, we want to guess A and B, so they're equal. In this case, their sum is -1, and their product is -6. And this could take some creativity. You might have to stare at this for a bit, like, gosh, what could that possibly be? But if you let A be -3 and B +2, well, -3 plus 2 is -1. -3 times 2 is -6. So that works. So now we'll do y plus -3 and y plus 2. And just to kind of, I don't know if we've talked about this very much, it comes up with negative numbers. But when you add a negative, this is the same as subtracting. And also, you can always rewrite subtraction as adding a negative. That does work. Y -3 is the same thing as y plus a -3. So now we use the zero product principle. If this equation is equal to 0 and we're multiplying two things, then this has to be equal to 0 or this has to be equal to 0. Something has to be 0 for the whole equation to be 0. So we'll add 3 to both sides. Subtract 2 on this side, on both sides. And so what we'll get, y is 3 and y is -2. And so those will be our answers. Questions about that? So let me do one more guess and check. Now, in this case, we're looking for two numbers that add up to -6, but multiply to 8. So thinking about this, and again, you can use negative numbers here too, but if we let A be -4, and B, -2. -4 plus -2 is -6. -4 times -2 is +8. So what that means, Z plus -4 times Z plus -2 is going to be 0. And again, if we're adding a negative, that's the same as subtraction. And so now we use a zero product principle. For this one, we add 4 to both sides. For the second one, we add 2 to both sides. And so our answer would be 2, 4. So that's the guess and check method. Questions about that? So the last method I want to go over, let me see, let me find some questions that'll work. So the last one, a little bit. Oh, well, let me show you another one with the zero product principle. So what we can do here, we can actually factor out a y. So if you recall the factoring, we have a y and a y. So we can treat this like there used to be a y on the outside that was distributed the 4y and the 20. So we're going to get this. So sometimes you're able to factor a variable out if the variable is on every term in the equation. Now this equation only has 2 terms, but we do have a y on each term. So that means we can factor it out. If there was like a +3 here, well, that 3 would not have a y attached to it. So we couldn't do this trick. So again, we can use the zero product principle. This times this is equal to 0. So that means this is the thing being the 0, or this is what's being 0, or maybe both. So you get 2 equations. That could be 0, or this whole thing. That could be 0. Well, this one's already solved. That's pretty nice. But this one, we got to do some more work. And then divide both sides by 4. And so we get our 2 answers, 0 and -5. So sometimes you can solve one of these by factoring out a variable. If you want to give a title for this type of problem, let's see, give myself some room here. You can give this type of problem that title, factoring out a variable. Oh. Missed. So that's another method that sometimes works if it's available. Here, I'll do another one. Let's say we have this. Now again, this has only, oh sorry, not r cubed, r squared. Now again, this only has two terms, but each term has an r. Remember, r squared is r times r. So we have an r and an r. We can factor out that r. And once again, we're going to get two equations. R equals 0 and r minus 3 is equal to 0. And this one, not too much more work to solve it. R equals 0, r equals 3. So we get 0, comma 3. That's going to be our answer. So questions about that? All right. So let me look. So the last method, and this is a complicated one for factoring. And again, these factoring methods, the guess and check, the factor out the variable, the if I'm going too fast, let me know. I might be getting a little zealous with my erasing. And then this other one called the AC method, they won't always work, but quadratic formula will work. All right. We're going to do, so the AC method's pretty complicated. So this is when you do have something attached to the x squared here. And you've got a number here, so you can't do any factoring or factoring out a variable. This isn't equal to 0. So what we're going to do, we're going to do this first. We're going to take the product of A times C, which is just AC. We'll do that. And then what we're going to look for is this. It's sort of like guess and check. We want a number A and B where they add up to this B, and then A times B is equal to AC, whatever this product was. So that's the first step. And then what we're going to do after that is something called factor by grouping. And we'll go through this when we get to it. But these are the first two steps, and then we're going to factor by grouping. So let's say we have this. Now, once again, we want this in standard form. Now, in this case, A is 2, B is -9, and C is -18. So first off, A times C, which will be 2 times -18, is -36. So we need two numbers, A and B, that add up to -9, but they multiply -36. And this is where guess and check could be kind of intense. You got to play with this a bit. But if you experiment, what you're going to find out is this. Let A be -12 and B be +3. And you might have to really play around with this to get it to work. Now, again, you can always use the quadratic formula. But if you do want to try using the AC method, you can try this. And again, some of these you can try like the AC method, and it's just not going to work. And at that point, use the quadratic formula. So -12 plus 3 is -9. And -12 times 3 is -36. So we've done the first two steps. Now we're going to do the factor by grouping. So for step 3, so this will be sort of step A. We're going to take that capital B that's in the middle, we'll rewrite it as little a plus little b. So then what we're going to do, and if you're concerned about how I got this plus sign, -12 plus 3 is -9. So plus a -9 plus a negative is the same as subtraction. So plus -9 is the same as -9. So you could just put a plus here if you want to, and if your numbers have a negative in it, it'll naturally work out. So We do that. The next step is we distribute that variable. And again, plus a negative. I'm going to rewrite that as just subtract. So the next step we're going to do is we group and factor out. So the way we're going to group this, let's group these two terms and these two terms. And what could we factor out of these two? And then what could we factor out from those two? Well, from these two, we can factor out 2x. Because there's an x that's common, there's also a 2. 12 is 2 times 6, and there's a 2. So we have a 2 and a 2 here. So we'll factor out the 2's. We'll get, well, there'll be a 1 and then the 6. And they'll have an x, and the x here will be factored out. Here, we can factor out a 3. And you could check this. 2x times x is 2x squared. 2x times 6 is 12x. 3 times x is 3x. 3 times 6 is 18. So next, and again, this is a long procedure. I'll do another example where I go a little faster without labeling all the steps. We're going to factor out a common expression. And for us, that's going to be the x minus 6. So the x minus 6 is going to be factored out. It's going to leave the 2x and the plus 3. And so that's what we're going to get. There's one step left and then we're done. Is it okay if I erase step C?
Yes, sorry, I was reading it.
No problem. So the last step will solve using the zero product principle.
Okay, I'm a little bit lost on that last one. Okay, so I know how you got x minus 6, and then you have the 2x plus 3. Is that because, oh, I see what you did. Okay, so you factored out x minus 6, one of them?
Correct.
Okay, I was just double checking.
That entire chunk gets factored out from both terms. And then you're just going to get it out here waiting to be distributed, but we're not going to do that. But you could distribute it back if you wanted to get 2x times x minus 6 and then 3 times x minus 6. You could do that. So the last thing, the zero product principle says, if this whole thing is equal to 0, then this has got to be 0 or this has got to be 0. So for this one, just add 6 to both sides. For this one, we got to do a little bit more. We'll subtract 3. Divide both sides by 2. And we'll just leave it as a fraction, -3/2. So for our answer, -3/2 and 6. Whew. So that's using the AC method. Now again, you could just use the quadratic formula. And so that's what I'm going to do next. And this will probably be the last example for today, is we'll take a look at how to do the same thing, but not with factoring, but with the quadratic formula. Let me look at those terms again. Okay. So again, we want it in standard form. And we're going to use the A, B, and C for the quadratic formula. Oh, 2a. So let me check this here. It's negative b squared 4ac divided by 2a. All right. So simplifying this, at 9 plus or minus the square root of 81, negative and negative, that's going to be plus. Let's see, 4 times 2 times 18. It's going to be 144 over 4. So 81 plus 144. So we got 9 plus or minus square root of 225. So we can break 225 down. Now, one thing you could always try to do is try the square root. And if you try the square root of 225, what you're going to get, let's see, is it 15? Yeah, you're going to get 15. So one thing with these square roots, before you break them down into prime factorizations, like we're about to do here, but if we take the square root, we're just going to get 15. And then we don't need to do the prime factorization. So the square root of 225 is 15. And now we can break this down into 2 solutions. So 9 minus 15 is going to be negative 6. 9 plus 15 is 24. So negative 6 over 4. Well, that reduces to negative 3/2. And then 24 over 4. Well, that's just equal to 6. And so using the quadratic formula, we're going to get the same answer. As we did using that very convoluted AC method. Questions about that? All right. Well, I think that's going to be it for today. So we're spending a lot of time on 9.4, but I think that's okay. This is a tricky section. So you have till Friday, actually, to get it finished. I scooted up one more day, and I'll post this video. If you have any questions, let me know. And other than that, oh, I gave you 2 extra attempts on it, too. So you have that. So other than that, that's it. So again, any questions, let me know. And other than that, have a wonderful afternoon.
Awesome, thank you.
No problem.